Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics.
Welcome to Speaking of Reliability. This is Dianna.
And this is Chris Jackson, and this is the first podcast Dianna and I are doing together.
Yes.
At the behest of one of our listeners. So we are in uncharted territory as well.
Yes, we are. Yeah, someone thought that we came from different backgrounds. Me mostly from quality, a little bit of reliability, and you a lot from reliability. Do you have any quality in your background?
Yeah, I do. You know, I teach a lot of SPC and PCA, for example. I do a lot of the statistics behind it, but mainly it's the mindset where you're trying to control a process and then refine the vital few parts of your typically manufacturing process that are going to give you trouble moving forward. And prevention is a lot better than the cure when it comes to making machines and things like that.
Yeah, absolutely. Yeah, in my background in quality, I was an operator on the manufacturing floor, and then I became a process engineer, and then a quality reliability engineer, and then I worked in product development. So I kind of got to see the life cycle of the product. And I started with like you said. Yeah, that's right. Like you said, SPC and control. But then as I worked with the design teams, I realized that there was a lot of opportunities for quality and reliability to be built into the design earlier. And I think you've talked to this at some other points in the past on speaking of reliability. Did you have a particular character that you?
Yeah. So I think the one you're talking about is the reliability fairy. And to be fair, I often use the term reliability and quality relatively interchangeably. And the reason I do that is because not because I believe that they are necessarily the same concepts, but I do believe there's a lot of useless argument about where the boundary between reliability and quality starts and finishes. At the end of the day, if it's a design or a manufacturing problem that's going to cause that thing to fail in the hands of a user, doesn't matter because it's what the user or the customer is experiencing. And often it's not the binary classification of a failure being a quality control issue versus reliability is somewhat nuanced, because some designs are just easy to manufacture. Designs which are harder to manufacture will have more defects. It's just, you can't talk about one without the other. So going back to that character, the reliability fairy is what I use in many of my courses. And reliability fairy is a necessary part of many product development life cycles I've come across, because there is this underlying assumption that all you need to do is get the reliability and quality guys or girls in at the end of a development process, or let's use development process broadly, where you're developing a product or you're developing a system to manufacture that product. And all they need to do is just be in that final meeting, throw the holy water or whatever it is, the fairy dust, over what has been done previously, and it's now reliable and high quality. And it's simply not the case. And
except when we don't sprinkle the holy water or the magic fairy dust. Because we have a different viewpoint of things, and you're kind of touching on it too. It's more of a systems and a customer viewpoint. Not that other people in the development cycle don't, but maybe it's more of that independent view. And just I guess a critique is the right kind of word, that we just see things, or we see unknowns, and we ask a lot of questions, because in the end, when we are brought in late, it is disappointing when we don't just agree and go along with the flow. We do have to argue our case and prove our point a little bit.
Right. And not only that, it's just, if you as a reliability or quality engineer are routinely only being brought in towards the end of the process, you are by definition going to have nothing but bad news. There's nothing you can do to improve your interpersonal skills or competency to change that fact. Usually the fact that these people are brought in towards the end of these development life cycles are a symptom of a broader cultural issue, which is going to be baked into the monstrosity that has been designed as quickly and as cheaply as possible up until that point. And it never ends well. And that's where you see a lot of adversarial relationships between the designing or manufacturing heroes versus the reliability or quality guys, in my opinion, or my observation.
Yeah, I agree. I've experienced that same kind of thing too. I have historically, on development teams, I kind of take the proactive approach where I'm a little bit nosy, and I'm not afraid to be nosy and sidle up to the design engineer. Hey, what are you working on? What new projects do you have? And just sort of not always jump in with advice right away, but sort of monitor the situation of product development to see where I can start helping to facilitate some ideas or offering my independent viewpoint. Because I think there's this general fear that they just want to keep the design to themselves for as long as they can without outside judgment. Whereas we're not trying to stop the design. We're actually trying to enhance it. We all have the same end goal in mind, which is to have a great product at the end. What's been your experience?
Yeah, I think that, and that's where you rely on interpersonal skills and the ability of the quality and reliability engineer to endear themselves to the design team or the manufacturing process development lead or whatever the right title is. And that's fantastic. We should always try and learn from others and people who have done this well, how to be, how to win friends and influence people. I'm a big fan of that. But the problem with that is that if your company or organization relies on having, let's just call it the A team for every step of the way, people who are just so competent and skilled and have those interpersonal skills, it's inevitable that you will have gaps in the system where that guy or girl wasn't available that day, or that guy and girl is not in your company anymore. And that's, so for that reason, I'm always concerned when that's the only safety net an organization has, the ability of a reliability or a quality engineer to endear themselves professionally. So the approach I like using is to motivate the design team, the manufacturing process development team to actually want to do it right in the first place. When I try and teach these courses or do these seminars or what have you, I always say there's actually 5 problems that a good reliability and quality engineer can eliminate for you. And the first problem is the one we're all familiar with, where the product fails in the user or customer. In fact, most textbooks and instructors tend to focus on that. There's, Fukushima, Chernobyl, Air France crash over the Atlantic Ocean. We have this collage of disaster and catastrophe and say, look at all these problems that we are here to stop. And the problem with that is that's not inherently motivating, because it's going to happen somewhat down the line. You're only part of a bigger team anyway, so your individual contribution to reliability might be lost in the noise. You have pressing short-term priorities where your manager's demanding on time, on schedule, et cetera, et cetera, et cetera. And so it's been my experience that this sort of blast of problem number 1 as a motivating tool doesn't work. But if we think about, and like I said, I categorize it into 5 different problems. The problem number 2 is a problem you uncover during manufacturing. Like you realize, this thing we're about to build or ship, there's a problem with it, and you only find out about it during manufacturing. Maybe the bonding isn't compatible with 2 epoxies or what have you. Now that is also a disaster.
Yeah.
And what usually happens is that companies knowingly make the wrong call because they've already used all their budget. They can't really change or retool or anything because they're already under the pump to be on time and on budget. There's nothing left in the tank. And so they ship knowingly defective products, which then quickly turn back into problem number one. So problem number two is also a disaster. Problem number three are problems you uncover during review, design review, process review teams. And the issue with finding problems out in that way is you have to build it first, let it fail, and then identify it, which is where you get all the delays and all the cost blowouts for your budget and schedule. Those let's wait till we build it before we find something out about what's going wrong. So
Right.
Good reliability and quality engineering means we don't have these problems because they're anticipated and prevented. Then there's problem number 4, which are problems that you uncover during initial testing. And these are fantastic because they're cheap. And I'm thinking about Halt testing or, very preliminary prototype testing for a process where you're trying to push your system to/beyond its limits in order to inform process design and design decisions. But problem number 5 is the best one, which is a problem that was never allowed to happen in the first place because you did a FMEA or something similar, anticipated this particular issue and designed a process or a system that never allowed it to happen in the first place. And once I get the foot in the door with that conversation, I can talk about companies and here is actual dollar figures associated with reliability and quality improvement initiatives, where we dispel the myth that reliability and quality actually blows out budget and schedule during development. On the contrary, if you get those people involved early, you're almost certainly going to breeze through reviews. You're going to breeze through qualification testing, and all of a sudden you'll be on time and on budget with a high quality, high reliability system.
Yeah, I like how you look at that as starting from the back end of when quality and reliability engineers get involved, that it is a disaster if it's discovered late. And then it progressively gets easier with the design process the earlier that we get involved. I like those 5 things. And I also come from it. I agree totally. I'm also a little bit empathetic to the design engineers, and I'm trying to help empower them to be able to do the outreach and to understand that early important work up front helps all those internal customers down the line. Everything that happens from manufacturing to service and from the user. I mean, the design engineers have a lot of internal customers, and they're also trying to manage all the external customers and the performance of the device. And at the beginning of design concept, before they're even starting to put engineering drawings on the board, it is hard to get that information to design against unless you do outreach to quality engineers and to reliability engineers and even your customers and your customer-facing counterparts, your teammates. So I encourage design engineers to use some systems. And, there's some quality tools, reliability tools that teams can use to start to gather ideas, and they can be iterated on throughout the development process, just to continue to inform and guide the group in some of those early design decisions. So, but it also has to be accepted and promoted by the people that are in charge of the whole design process, right?
Right. And if there's this, if you have this overbearing perception that budget and schedule are king, then you you reward short-term thinking where the manager or the design team lead or the process development team lead who gets to the first milestone in whatever way possible as fast and as cheaply, faster and cheaper than anybody else, that person gets rewarded, then essentially all those wonderful problems, the 4s and the 5s, essentially they are never allowed to happen. And they're the same problems as 3, 2, and 1. It's just that they're going to occur later when there's something you can do about it. So it really comes down to the culture and the leadership at play. And yes, there's been organizations where you've had fantastic personalities in the reliability and quality team. But that's something, to be honest, that's something you can't really bank on because humans are variable creatures themselves. And one of those, if you rely on the charisma and personality of a single quality engineer, and that person gets a better job somewhere else, well, that's your entire product line done.
Yeah.
It's not the first. It's this challenging scenario that there's so many listeners are unfortunately familiar with.
Yeah, the systems part is hard, especially if you're a staff engineer working on a team. But I do think that you do what you can where you are, and demonstrate, be the best quality reliability engineer that you can be, and demonstrate how things can be better with more upfront work, or facilitate some of those meetings with the design engineers, and try to teach them how to use that. And that's sort of what happened in a previous job that I had. I was a quality engineer responsible for FMEA for a medical device. So the FMEA had to get done to meet regulation and the requirements no matter what. So we would do them, and I would push to do them early and iteratively. And I got moved to another division, another project, but a product design engineer said, you know what, I'm at this point in my design development that I want to do an FMEA, but the quality engineer doesn't have enough time to help me.
Ooh.
What should I do? Well, do what you can, So I coached him through doing FMEA and keeping in touch with the quality engineer so that he could use that for his own design. So even though we're staff engineers and we may not be in control of, the big product development cycle, we can still model those good things that might have a lasting effect on our teammates, and find those things early.
And what it sounds like is that you were helpful to one of your internal customers. And that's, I think, one of the keys. If you're, like we talked about, how if the reliability or quality engineer is brought in late, they're almost certainly going to be the bad guy or girl.
The stop police or holding the big red button. Yeah, the big red no button. Yeah.
Right. But if the mindset of a reliability engineer or a quality engineer is to make the lives of those around you easier, then you're going to get more traffic in a good way. And that then leads on to the perception of value for what it is you do. And with any luck, that will then reinforce and then be passed on. And you are now, through just being helpful, promoting the concept of what it is you do in the first place, which then makes your job even easier next time. That sort of sounds like what you were doing in that scenario. Is that about right? Is that what you were trying to achieve?
Yes. Yeah. And in trying to empower the people that are doing the design work, empower them with some of the tools and techniques that I had learned, like a user's process. There's a lot of things you can understand about the user before you start product design. And there's a whole field of usability engineering based on that. But you can borrow a lot of things from the manufacturing processes to use to evaluate your user's process. And they don't have to be cumbersome. And they are graphical, and they can be team-based. But just trying to learn what's out there and do that outreach with the rest of the team. I think for design engineers themselves too, it's important.
Did that medical device become let's call it reliability and quality success as a result?
Yes, that one did.
Excellent.
There were other ones where it was like a number 3 or a number 2. Like you mentioned, there was this unforeseen problem, and the project ended up getting scrapped.
Oh, that's no good.
Yeah.
That's a disaster. And that is that true. I mean, that's devastating. And I think that's a very good, you don't want to be a scaremonger, but by the same token, if there's that genuine understanding that if we don't meet our internal milestones for development, the company might just cut us away anyway. So you don't want to waste all that effort, especially if you just don't want to waste all that effort, period.
Yeah. Yeah.
It's demoralizing for an engineer.
But it happens. And it was the right decision not to ship that product. Yeah.
Right.
But it was devastating for the whole team. It's a disappointment.
Yeah, and so I think that's a good lesson to be learned, and hopefully, I mean, especially when you're doing developmental stuff, and I don't know the medical device you're talking about, but having worked with plenty of medical companies myself, device companies myself, they're usually the cutting edge of what technology allows. There is a risk that it's just not going to pan out. Just want to make sure if it doesn't pan out, it's not because you held on too tightly to your design and shielding it from external review, so you wouldn't have to hear bad news, because the bad news is going to come one day. It's just, wouldn't you rather you hear the bad news when it's really cheap and quick to do something about it? That's the sort of message I like sending as well.
Yeah. Well,
but anyway,
I think we started out with, how do we get involved earlier, the importance of getting involved earlier, and that it is challenging. And there's the best thing to do is to have it recognized and built in within the leadership and within the product development process. And we can also model and showcase and do what we can with the projects we're involved with to provide value to the other people on the team. And that will promote better engagement with quality and reliability. Do you have anything else to add, Chris?
No. I just think I think you talked extensively about the power of the personality, and I think I may have spoken more extensively about the cultural motivation for doing it. But the reality is, you need a healthy dose of both. And I think that as a reliability and quality engineer, it's just, if you can try and motivate those around you to take what it is you bring seriously, and that means you're there to help, not there to lecture. But by the same token, you're not the reliability fairy or the quality fairy. That doesn't exist.
Right. Yeah, you'll have to add the quality fairy to your repertoire if she's not.
She's ugly. That's so it'll be. So maybe the quality fairy's ugly sister. So maybe they're both ugly. So but that's the point. It's an absurd caricature. Pretty happy with it, to be honest with you. But yeah, it's this that we can't help if you've already spent your entire budget on producing whatever it is you produced. You can't test your way into quality and reliability. But I think we covered the two main aspects of making it happen.
Well, I think together we could probably move mountains if we were the same company. Yes. Well, I'm going to finish out like Fred does, and I'll offer any comments on the episode, any additional insights, anything you want to add, or even if you have a different question, if there's another topic you want Chris and I to explore, you can go to accendoreliability.com/go/SOR, short for Speaking of Reliability. And Chris, thanks for jumping on a first call with me.
Not a problem. It was a pleasure.
Yeah, me too.
Cheers.
Cheers.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.